So hello friends, this is Kausu Patare and again with a new video. Welcome to our channel Making Maths Easy. So in the previous video we have solved the sums based on integration of algebraic expressions, different methods of integration as well as the trigonometric formulas. So today in this video we are going to solve the sums based on the method of integration, the first method of integration, that is the method of substitution. So let's start our video. So the first sum we are having over is here is the log x raised to n divided by x. So let us consider that capital I be an integral of this corresponding function, and here we write dx, and which will be equal to, now we will do an substitution, we will use the substitution theorem over here, property of substitution. So put log x equal to t, in this case put of log x equal to t, and then 1 upon x 1 upon x dx, 1 divided by x dx equal to dt. Okay, so instead of log x we have to put t, and instead of 1 upon x dx we have to put dt. So let's solve. So my capital I will be equal to integral of log x means t raised to n, because log x is raised to n, and where n is the constant, and 1 upon x dx equal to dt. So instead of 1 upon x dx we will write dt. So which will be equal to, as we know that integration of x raised to n is equal to x raised to n plus 1 divided by n plus 1. So integration of t raised to n with respect to t will be equal to t raised to small n plus 1 divided by n plus 1. Now n plus c, where c is the constant of integration in this case, and we will now resubstitute the values of t. So the value of t is equal to, my t is equal to log x, so which will be equal to log x raised to n plus 1, log x raised to n plus 1 divided by n plus 1 plus c, where c is the constant of integration. So in this way you have to substitute the value, and then we have to bring it in an integral form, and then we will integrate, and again we have to resubstitute the values which we have substituted earlier. So the next sum we are having over here is the x plus 1 divided by x into sine of x plus log x. So let us consider this corresponding function equal to, let I be an integral of, let capital I be an integral of the given function, and dx we will write. So in this way we have to substitute the value and bring the answer. So for this sum we are having over here is the integral of x plus 1, and we are having x in the denominator. So we will do one thing, we will divide this small x in the denominator with this expression which is in the numerator. Okay, so after dividing with, we will get x plus 1 divided by x, and this sign means that sign of x log x we will write it afterwards. So 1 multiplied by sign of x log x and dx. So now there is we will do one thing, we will put x log x is equal to t. In this case we will substitute the value of x log x equal to t. So let us substitute the value of x log x equal to t. So x plus log x equal to t, and then find the derivative of it. So 1 plus 1 upon x, 1 plus 1 upon x, and put a bracket, dx equal to dt. So instead of 1 plus 1 upon x dx we have to write dt. and this x is multiplied with this 1 after taking the LCM. So we will get this expression as uh, x plus 1 divided by x dx equal to dt. So instead of x plus 1 dx, we will write x plus 1 dx, we will write dt, and instead of x log x, we will write t. So let us substitute. So my integral will be equal to integration of 1 divided by sine t. So 1 divided by sine t, we are having in the denominator, not in numerator, and then x plus 1 divided by x dx is equal to dt. So we are differentiating with respect to t, sorry, integrating with respect to t, so we will write dt. Now we will integrate it. So 1 upon sine t is equal to cosec t. So my integration, we have to take the integration of cosec t in this case. So cosec of t and dt. So integration of cosec t will be equal to log of cosec t minus cot t plus c. So integration of cosec t is equal to log of mode of cosec t minus cot t and close the mode function plus c, where c is the constant of integration. Now we will do one thing, we will resubstitute the values of t. So my t is equal to the value of t is equal to x log x, which I know. So we will resubstitute the values. So my integration will become log of mode of cosec of log x plus log x minus cot of x plus log x, and then close the mode plus c, where c is the constant of integration. So we can also make it more. We can also simplify this corresponding function and make it in the simplest form. We will do it. So log of mode of cosec is equal to 1 upon sine. So log of mode of 1 divided by sine of x log x minus again cot is cos upon sine, so it will be equal to cos of x log x divided by sine of x log x, and then put a mode function and plus c. Now we are having denominator the same values, only the thing is the numerator. Only the numerator value we have to change over here, and denominator is same. So this can be written in such a format as equal to log of mode of 1 minus cos of log of mode of 1 minus cos of x log x divided by sine of x log x and close the mode function plus c. So in this way we have to integrate the given corresponding function. So we have integrated the given corresponding function, and we have used the method of substitution for integration. So let's solve the another sum. The third sum means tan 2x into tan 3x into tan 5x. This sum is a tricky type of a sum, so tricky type of question. So tricky question, we are having three tan terms which are multiplied with each other. So this is very easy, but a tricky question which can be asked for the exam for 4 marks. So let us consider that, let capital I be equal to tan 3x into tan 2x into tan 5x. So equal to tan of 3x into tan of 2x into tan of 5x in this case. So now we will do one thing. We will first consider tan 5x. So we know that tan 5x is equal to tan 2x plus 3x, because 2 plus 3 equal to 5. Okay, so now we will do one thing. We will use the formula tan a plus b. So which is equal to, according to the formula, this expression is equal to tan a plus tan b divided by 1 minus tan a tan b. So tan of 2x plus tan of 3x divided by 1 minus tan 2x into tan 3x, according to the formula which I have told you in the previous video. The previous video was on the trigonometric formulas. So now we will multiply this uh, denominator with this tan phi x, because tan phi x is equal to tan 2x into tan 3x. So my expression will look like this. So tan of phi x equal to this combined expression, and then we will do one thing, tan phi x multiplied by this function in the denominator. So tan phi x is multiplied with this, and which equal to tan 2x plus tan 3x in real sense. So which is equal to tan 2x plus tan 3x. Now we will perform the complete multiplication. So after opening this bracket, we will get as tan of phi x minus tan 3x tan 2x tan phi x, because tan phi x has been multiplied inside the bracket, which is equal to tan 2x plus tan 3x, and then we will do one thing, this minus tan 3x, tan 2x and tan phi x will go on the right hand side over here, and this tan 2x plus tan 3x will come on the left hand side. So after coming this on the left hand side, this tan 2x and tan 3x will become minus, or it will become minus tan 2x minus tan 3x, and this minus tan 3x minus tan 3x 2x tan 2x tan 5x will become positive or become plus on moving on the right hand side. So it will become tan 5x minus tan 2x minus tan 3x equal to tan 2x tan 3x tan 5x in real sense. So instead of tan 2x tan 3x and tan 5x, we can also write tan 5x minus tan 2x minus tan 3x in real sense using the formula. So this only this function we have to integrate. No need to integrate tan 2x tan 3x and tan 5x, because tan 2x tan 3x and tan 5x is equal to tan 5x minus tan 2x minus tan 3x using the this tan a plus b formula. We have proved it. So instead of this, we will write this corresponding function, only this corresponding function. So let us take an integration of this function. So integration of this combined function, we will put a bracket. So dx will be equal to, so first consider the integration of tan of phi x. So the integration of tan x will be equal to log of sec x plus c. So we will write over here as 1 upon a, means 1 upon 5 means 1 upon a log of sec x. So 1 upon phi log of mode of sec of phi x, and close the mode function, minus 1 upon 2 uh, 1 upon 2, then again log of mode of sec of 2x, close the mode, and again 1 upon 3 into log of mode of sec of 3x and plus c, where 3c is the constant of integration. So this phi this 2 we have taken because it's a derivative of 2x. As I told you in the previous integration videos, that we have to divide its loop derivative, and whenever we are integrating any function and whenever we are multiplying any function, we have to multiply the loop derivative. So the same thing we have done over here. So the integration of tan x or tan phi x or any tan function is equal to log of sec x plus c. So in this way we have to find the given corresponding equation, given corresponding integration, and we have to find the appropriate answer. So this may come in the examination for 4 marks. It's a tricky question. So hope you like the video most. This is a part 1 video of integration using the substitution method. So I will also make the part 2 video soon. So if you like the video, please share, subscribe and comment on my YouTube channel Making Maths Easy. For more videos related to mathematics, please subscribe my channel. Please press the bell icon, so if I upload any new video, so you can get a video notification. So thank you for watching. Thank you guys.